Bismillahirrahmanirrahim and Assalamu alaikum guys. I hope you all are good. This is Noor and in this video I'm going to tell you about the Earth satellite, that is MoOn. So in this video we will be discussing the definition of satellite, MoOn, and the origin of the MoOn, hypothesis, Saros, and many more things in this video. So let's start. So firstly, we are going to discuss about the satellite, that we are saying that MoOn is a satellite of Earth. So before moving to that, we have to know that what is satellite. So satellite is a MoOn. It is a planet or machine that orbits a planet or star. For example, if we say that MoOn is the satellite of Earth, so MoOn is orbiting around the Earth, so it is a satellite. If we will be discussing about the Earth, so Earth is also a satellite that orbits the sun. So that is basically the satellite. Usually, the word satellite refers to a machine that is launched into space and moves around Earth or any other body in space. And next one is MoOn. The MoOn is Earth's only satellite. The Earth's only satellite is MoOn, and it is a very cold, dry surface. A dry surface and whose surface is studded with craters. Craters mean depressions, some holes, and strewn with rocks and dust called regolith. And the surface of MoOn, which is studded with, which is composed of rocks and dust, that is called as regolith. And the MoOn has no atmosphere, and recent lunar missions indicate that there might have been some frozen ice at the poles. So it has proved, it has experimented, some astronomers have experimented that that frozen ice is present at the poles of the MoOn. So is it true or wrong? What we cannot say anything about this. We cannot say anything about that until we get to know the real thing. So let's move to the first hypothesis about the origin of MoOn. So the first hypothesis of the origin of MoOn was considered as that MoOn was originally a small planet. It was a small planet that orbited around the sun and that slowly approached the Earth and was captured by its gravity. That MoOn was a small planet and it used to orbit around the sun, and slowly while orbiting the sun it approached the Earth, and the MoOn was captured by the Earth's gravity. So the young Earth initially spun even more faster than now. The Earth, which captured the MoOn by its gravity, it started to spin more faster than now, and it formed a bulge that tripped away from the Earth to become the MoOn. So that was just considered a bull story, but it wasn't true. It was not accepted. So the second hypothesis that was accepted was the giant impact hypothesis. So it was largely accepted theory, and what was that? Let's see. The giant impact hypothesis, sometimes called the big splash or the Theia impact, it has three names. The giant impact hypothesis, sometimes called the big splash or the Theia impact. So it explains that Luna, the MoOn, formed from the collision between the proto-Earth and a Mars-sized planetesimal approximately 4.5 billion years ago. So it was suggested that the formation of the MoOn was done by the collision between the proto-Earth and Mars-sized planetesimal approximately 4.5 billion years ago in the hidden eon, about 2200 million years after the solar system coalesced. So means after the formation of solar system, the MoOn was formed. The colliding body is sometimes called Theia, and from the name of the mythical Greek Titan, who was the mother of Selene, the goddess of the MoOn. The goddess of the MoOn, we say Chand ka Devta, the goddess of the MoOn. So the Mars-sized planetesimal is also called as Theia. we say the colliding body is sometimes called Theia. So the Mars-sized planetesimal is also called as Theia, and its name was taken from the mythical Greek Titan. And mythical Greek Titan, who was he? He was She was the mother of Selene, the goddess of the moon. We say the Chand ka devta. So she was the mother of the Selene. Analysis of lunar rocks published in a 2016 report suggests that impact may have been a direct hit, causing a thorough mixing of both parent bodies. So that's how the formation of moon caused, and that is the largely accepted theory in the whole area. So let's see the evidences of authenticity of the giant impact hypothesis. So the giant impact hypothesis is currently the favored scientist hypothesis for the formation of the moon. Supporting evidence includes like Earth spins and the moon's orbit have similar orientations, and moon samples indicate that the moon's surface was once molten, but now it is not molten, and Earth's surface is molten and moon surface is not molten. The moon has a relatively small iron core, but Earth has more iron core, and the moon has a lower density than Earth, and there is evidence in other star systems of similar collisions resulting in debris disk. And there are more evidences for the giant impact hypothesis as these. So giant impact theory can be explained through this diagram very easily. We can say that here in this picture you can see that impactor comes to strikes the earth and causes the destruction of the earth. So how it goes on, the impactor comes and strikes the earth, and it destroys the earth, and that's how the destruction of earth happens. And then after 8.4 minutes after the impactor strikes the earth, and then the impactor causes the destruction of the earth, and then the giant impact quickly propelled a shower of debris from both the impactor and earth into space. So that's how the whole debris from the earth and the impactor was propelled out into the space, and the impact sped up the Earth's rotation and tilted Earth's orbital plane 23 degrees. So the debris was propelled out, and it started to make small objects, and those small objects which were called debris and which were propelled out from the impactor and Earth started to reform and started to make a larger one object, and that one larger object then started to rotate around the Earth, and that's how the moon was formed, and moon began to orbit the earth. So that's how the giant impact theory shows the formation of moon, and that's the most acceptable theory. So what is the moon? A natural satellite, one of more than 96 moons in our solar system, but the only moon of the our planet is Luna moon. Moon's location from Earth, if we see, about 384,000 kilometers is distant from Earth, and its diameter is 3,468 kilometers. And where does the moon get its light? That's a very interesting question. Whenever the moon shines, it is reflecting light from the sun. It means that whenever the moon shines, it is reflecting the light from the sun. The sun's light strikes the moon, and when the moon starts to shine, it reflects back, it bounces back its light to the sun. And then what is Saros? Saros is the roughly 18 years period cycle of the earth, moon and sun system. So every 6,585 days, the earth, moon and sun are in exactly the same position. So when the earth, moon and sun will be in the same position, it will be called as Saros, and it happens every 6,585 days after. It happens exactly after 18 years after. So when there is a lunar eclipse, there will also be one exactly 6,585 days later. So we can observe that that if there will be a lunar eclipse, then after 6,585 days, it will the sun, moon, and the earth will be in the same position. So let's talk about the atmosphere of the moon. The moon has no atmosphere. On the moon, the sky is always appears dark, even on the brighter side. And also, since sound waves travel through air, the moon is silent, and there can be no sound transmission on the moon. No atmosphere, so no sound waves, and no sound transmission on the moon. So these three people, and these are the first humans to land on the moon. They went into the space uh, and saw the surface of moon, but they themselves don't know that whoever ever took this picture of the moon. And in this picture, as you can see, that in 1969, the Apollo program landed Neil Armstrong and Buzz Aldrin on the moon during Apollo 11. So the first two persons who landed on the surface of moon was Armstrong and Buzz Aldrin. So on July 1969, when they went into the space or the surface of moon, it was a four-day trip. The Apollo astronauts arrived at the moon, and this photo of Earth rise over the lunar horizon is one of the most famous images returned from the space program. Although even the astronauts themselves cannot remember who actually took it. So, first steps on the moon on July 20, 1969 by Neil Armstrong and Buzz Aldrin. And then there's a small comparison between the earth and the moon, that earth is an active wind, and there is always water erosion, but on the surface of moon there is no active wind, because it has no atmosphere, so there will be no water erosion. But if we talk about the earth, there are impacts, like active volcanoes are there. There are earthquakes, there are active magnetic field, and few craters. But if we talk about the moon, it has no active volcanoes. It has small moonquakes. Earth has earthquakes, and moon has moonquakes, but it is also small. Moon has also no active magnetic field, and it has buckets of craters. If we As we have discussed about the earth, that it has few craters, few depressions, but in the case of moon, it has buckets of craters. So these all types and these all characteristics prove that earth is geologically active, that it has volcanoes, earthquakes, magnetic field. All these show that it is geologically active. But if we talk about the moon, it is geologically inactive. The moon's surface. So when the sun's light reaches the moon's surface, it also bounces back some of the light. So the amount of sunlight that the surface of moon reflects is only 7%. Is only 7% contrasted with the Earth's average, that is 31%. So Earth reflects back the light 31%, but moon reflect back the light 7%. It has no atmosphere, no liquid water, and its extreme temperatures in daytime is 120 degrees Celsius, and nighttime it is minus 130 degrees Celsius. So here we will discuss about the movements of the sun. As you can see in this diagram, that there are some depressions. So these are called as craters. So if we talk about the movement, so moon orbits the earth, as it is the satellite of earth. It orbits around the earth. So moon orbits the earth every 27 days. After 27 days, it orbits around the earth, and it completes its revolution. And if we talk about its rotation, the revolving around its own axis. So moon turns on its own axis every 27 days. So the same time period is shown in revolution and rotation days. The moon rises in the east and sets in the west, and the moon rises and sets 50 minutes later each day. So same side of moon always faces earth, because we cannot see the backward side of the moon. So same side of moon always faces earth. And if we see the far side of the moon, the backward side of the moon, so it can be seen that there are many depressions, many craters mean depressions, some holes and thicker crust. So this is the back side of the moon. And phases of moon, as you can see in this diagram, that new moon, then last quarter, then full moon, then first quarter. And these upper things and lower things are as same as these, like new moon, then one in crescent, then last quarter, then one in gibbous. And that is the whole cycle of the moon and phases of the moon. Lunar formation models. So the moon is the sister world that formed an orbit around Earth as the Earth formed. So as the Earth was formed, the moon was also formed exactly after it. So the moon formed somewhere else in the solar system, then was captured into orbit around Earth, and it started to move around the Earth, and it started to complete its revolution, and revolution is 27 days. Early Earth spun so fast that it spun off the moon. And if we see the lunar geologic history, so 4.5 billion years ago, our moon was formed. And as you can see in this diagram, the impactor attacks the surface, and then it causes the destruction of the surface, and that's how the inner material was propelled out into the space and started to cause a depression, that is a hole crater that caused the depression and the backward side of the moon. So the last one slide is of the characteristics of orbit. Characteristics of orbit consist of two main components, that is, one is apogee and the second one is perigee. So apogee is the farthest point on the orbit of a satellite from Earth. So on the surface of Earth, the farthest point which is from the Earth is called as apogee, and in contrast with apogee, if we see the perigee, so the nearest point on the orbit of satellite from Earth is called as perigee. So that's how the whole formation of the moon completes, and the characteristics, its evidences are concluded. So I hope you all will get it, and in the next video we'll we will learn some new skills and some new ideas and some new things. So till then, take care. Allah Hafiz.